Okay, so 6.4, sum and difference formulas. You can see that there's a lot of formulas going on. You would think that it'd be so hard for you to remember these, but it's not actually. It's really not, okay? Once you start using them a few times, especially when you start doing your homework, after that first day of doing homework, you're going to be able to have these in your head, no problem. And then these might take like another day or so, but you'll see the pattern that emerges, okay? So here's what we're doing. So basically, not every, like you're trying to find sine of whatever, right? Not every sine value has a unit circle value. So it's really hard to know what that answer is if it's not on the unit circle. You need a calculator for that. But there are some cases where you can use sums and differences of things that you do know, and you're able to find an answer. So I'm going to show you examples of that, okay? So these are already on your paper. So these are our new formulas. So the sine of something plus something, like let's say we want to find the sine of like 75 degrees. Then we could do 60 plus, no, not 60, just kidding. We could do 30 plus 45, right? We know the sine of 30 degrees. We know the sine of 45 degrees. So we know sine and cosine of those angles on the unit circle. So we can use this formula and do the sine of something times the cosine of something else plus the cosine of something times the sine of something else. So this is actually like really easy to remember once you start using it, okay? So in the beginning, it's like kind of crazy looking. These cofunction identities. So this is kind of hard to understand for a lot of us, but if I asked you about cosine of, let's say, 90 degrees minus 30 degrees. So that would be the cosine of 60 degrees. The cosine of 60 degrees, we know, is the same as the sine of 30 degrees. So we know this to be true, right? So when we look on the unit circle, or when we use our left hand, the cosine here, the root 3 over 2 of 30 degrees is the same as the sine, root 3 over 2 of 60 degrees. So we know that this is true, and we can kind of like understand it this way, but when we see it this way, it seems really weird, right? But isn't this just 90 degrees? So 90 degrees minus theta is the sine of that value. So it's the same thing, it's just written a little bit differently. This is our cofunction identities. So basically just realizing that this is the same thing, okay? Anytime you do 90 degrees minus, it's the same as our cofunction. Okay, so that helps a little bit later. If you don't memorize this and you just use these formulas, that's actually okay. It's not a big deal, okay? All right. So for these, it's already on your paper. I'm not going to explain them fully. I'm going to go over like a few of them, all right? Just a few of them. So I'm not going to go through this one fully, but like I said, if you have the sine of 75 degrees, there's no 75 on the unit circle. Instead, we can do 30 plus 45. So that makes 75. And then we can use our formula, and then we can use the values on our unit circle. So let's talk about this one, 15 degrees. Okay, so what gives you 15 degrees? On your notes, I know it's already there, but I want you to think about what gives you 15 degrees. Did you automatically come up with this one? Please say no, because what else can you use? Think of something else that you know from the unit circle that you can use instead. So you can actually do, what, 45 minus 30, right? 45 minus 30 is also 15 degrees. If you do 45 minus 30, you'll get the same answer, but let's see how this works. So sine of alpha minus beta. So that's, oh, these are alpha, and that's beta, by the way, like alpha, beta. I feel like there's like a supermarket. I don't know. So sine of alpha minus beta. What's the formula for sine of alpha minus beta? It's going to be sine of alpha cosine of beta minus cosine of alpha sine of beta. So these are not crazy to remember. We just, you know, instead of a plus, this is a minus, okay? So it's sine of one, cosine of the other, and then minus. All right, so what is the sine of 60? So on the unit circle, which you don't have to check because you already know it, you're using your left hand, you have these values, and then you multiply them together, and then you get that, and then you can leave it like that, or you can factor out the 1/4, and then you can leave it like that. Okay, so it's up to you. So the only other one I wanted to go over, even though it's on your paper, is this one, because this one seems a little weird, right? So the tangent of pi over 12. The tangent of pi over 12, you can, if you want, use addition or subtraction. Well, you're not going to use addition, right? So that's not going to work. Subtraction would work. So what can you subtract of, radians that we actually know for tangent? Well, we can use, so if you think about it, you'll get used to it after a while. I know it takes a little bit of time, but we have like pi over 3, pi over 4. So pi over 3 is actually 4 pi over 12. 3 pi over 12 is pi over 4, right? If we subtract this, don't we get that? So from here, we go to here, and then we realize that this is the same as this. And now we can use our formula, that subtraction formula right here is going to be tangent alpha minus tangent beta over 1 plus. So if it's a minus on top, it's a plus on the bottom. And then you just multiply them together. Okay, so it was tangent alpha minus tangent beta over 1 plus. So right here, I'm going to cover this. Tangent alpha minus tangent beta over 1 plus. And then these two get multiplied together. Okay, what is tangent pi over 3? It's root 3. What's tangent pi over 4? It's minus 1. What is 1 plus? We just leave it 1 plus. And then what are these two numbers multiplied together? If you multiply them together, you get a negative root 3. Right? Actually, if you multiply just the numbers together, you get a root 3. Okay, so there's that. And then that's not a final answer because we're going to rationalize our denominator. Ooh, this has been a long time. Okay, to rationalize this denominator, we need to use the conjugate. The conjugate of 1 plus root 3 is 1 minus root 3. So we're multiplying technically by 1, so nothing's actually changing, but we need to get rid of that root. So multiplying by the conjugate on the top and bottom, you FOIL the top, and on the bottom, you should know what you get on the bottom. You get, when you have a plus b times a minus b, it's a squared minus b squared. So it's 1 minus 3 on the bottom. Okay, so you multiply it out, and then you get this on top, and then 1 minus 3, and then you work with the top, and this is not really okay, because you can divide it. And when you divide it, you get a negative root 3 plus 2. So it looks a little better if you have that positive and then a minus. Okay, so that one was kind of tricky. So that's the annoying part, I would say, about tangents, is that you sometimes have to rationalize that denominator. Sometimes you do this and then you get an answer that's really nice looking, but other times you have a radical on the bottom and you gotta multiply by the conjugate. Okay, so take a look at the other problems on this side. You're going to be doing these problems for homework pretty soon. And then you're going to ask me questions about these the next time I see you. But then you're going to also fill in a little bit of the notes on the back. Okay, so we're going to fill in a little bit of notes on the back. So, given these values, so this is given, this is actually the problem. What you want to do is draw triangles. So, you know when you're given an angle and you don't know what the angle is for theta, you have to draw triangles. So same thing, except there's two angles. There's an alpha and a beta. So we're going to draw two triangles. Where are we going to draw them? There's 4 quadrants. So this is not a sine inverse, okay? This positive sine value, this can be in quadrants. Think about a positive y value. This can be in quadrants 1 or 2. And then this breaks it down for you. This means between pi over 2 and pi. Well, what quadrant would that be? If you go around the unit circle, pi over 2 and pi. Oh, that's quadrant 2. This is in quadrant 2. I'm going to draw my alpha in quadrant 2. How about this? Beta. Cosine is negative. Okay, this is not a cosine inverse. Where is cosine? Where's the x value negative on a unit circle? Well, xy, right, here's x. So x is negative in quadrants 2 and 3. Okay, so I have 2 quadrants to choose from, and then they tell me exactly. So they're like, oh, this is from pi to 3 pi over 2. That's quadrant 3. Okay, so this is in quadrant 2. This is in quadrant 3. I'm going to draw alpha in quadrant 2, beta in quadrant 3. So we have to draw 2 triangles. I'm going to go ahead and do that and show you. So quadrant 2, here's my opposite over hypotenuse. This must be a 3, 4, 5 triangle. I know that's a negative because it's in quadrant 2. Quadrant 2 has negative x, positive y, right? Okay, and then this one, cosine is adjacent over hypotenuse. So my adjacent to angle B in quadrant 3, this quadrant 3, is negative 2 because my hypotenuse is always positive. And if I'm in quadrant 3, I have a negative and a negative y. So I do my Pythagorean theorem, I get a negative 1. So again, with those triangles, they still exist, okay? They're still there. Okay, so my first thing I'm going to do is I'm going to go ahead and find, they want you to find, this is still part of the question. So they want you to find cosine of alpha minus beta. So we're using the triangles to help, but we need the formula for cosine difference. So cosine difference formula is cosine cosine plus sine sine. So it's pretty easy to remember once you use it a few times, okay? So write the formula first. And then you're going to fill in. So how are we going to fill it in? What is the cosine of alpha? The cosine of alpha is adjacent over hypotenuse. What is the cosine of beta? The cosine of beta is adjacent over hypotenuse. So you literally just write it in, and you use these alpha and beta to fill in opposite over hypotenuse and opposite over hypotenuse using alpha and beta triangles. And then you multiply, and then you keep going, and then you rationalize. And then there's your final answer. Okay, I'm going to try one more. And for this one, you're doing, let's see, tangent. So let's try tangent. Tangent of alpha minus beta. Okay, without flipping your paper around, I know you just saw it for like 2 seconds, but do you remember what that formula is? I want you to try. I want you to try to think of it, and if it's wrong, it's fine. But try to think of the formula. Okay, I think it's tangent alpha minus tangent beta over 1 plus, and then tangent alpha, tangent beta. Let's see. Yeah. Because I just looked at it. I swear. I don't remember it from last year. I promise. So tangent alpha minus, and then 1 plus. Okay. And then I fill in. So what are you going to fill in? What is tangent alpha? I look at alpha. Tangent is opposite over adjacent. Opposite over adjacent. So this is actually 4 over negative 3 minus tangent of beta. Opposite over adjacent. So 1 over 2. Right? You don't have to write negative 1 over negative 2. You can just write 1 over 2. Over 1 plus, and then you take that number, and you take that number, and you write them right next to each other. Like that. And then you keep going. And, oh, how do we keep going? Well, we need common denominators here so that we can subtract it. And then this one we just multiply. So, oh, I didn't finish. Okay, you finish. All right, I'm going to put this on the homework outline. So, homework outline. I'm going to put that in, and somebody's going to volunteer for that, and then you're going to finish it, and we're going to check that answer together. Okay? We're going to do number 4 and number 5 together in class, and then you'll try the homework after that. Okay? So go ahead and, check this. See if somebody's done it yet. Otherwise, you're free to do it. And then we'll do number 4 together and number 5. All right. I'll see you later.